Thanks very much, Ben. Sorry, getting this all set up. I'm sharing this. All good? I think I'm actually going to do quite a different talk than everybody else. We'll see how it goes. I am on the Slack channel. I've got it up if anybody wants to fire questions. Actually, I said I have it up. Now I've got it back online. Since it's careers in quantum, I'm going to tell you about a career in quantum, me, because I think there's lots of stuff you can read about KETS on our website and things like that. Though I'm happy to answer any questions you might have about KETS. And I will say at least a tagline of what we do in a second. But yeah, I'm going to give you a bit of background of how I ended up with a career in quantum, just as an example, and certainly an imperfect example of how you can still end up with a reasonable career in quantum. So I started as a systems design engineering student at University of Waterloo. Some cool stuff about it was I did 6 co-op work terms. So for 4 months at a time, I worked with some massive companies like Atomic Energy, all the way down to some multiple startups that were doing some different things, as well actually as a university teaching assistant. And it was a purely by chance second year lunchtime talk by Michele Mosca, who was helping start this Institute for Quantum Computing thing. They came in and gave a talk to a class on quantum crypto, which sounded kind of cool. And I'd always had a passion for physics. Had no idea how to make some money from it, and avoid just being a teacher from it. But this sort of got me interested, and very much I wanted to make sure that people realize you don't have to be perfect to get into these things. So a fun fact for me is my second year mechanics of deformable solids course. I got 51% on it. And if you're from the North American system, you know that we use the full 0 to 100 scale, and 50 is a pass. So I barely passed. And I passed because I got 20 out of 20 out of, we had a bridge building experiment where in a team, I think I helped predict to, I don't know, 1% or something when our popsicle bridge was going to fail. But it was also a good, it showed me it was the first year I had to work hard. High school was easy somehow, or easier. I could usually do the homework by just reading the textbook. University was starting to get hard where I had to work at it. But this showed that I could still do it because I got that exam question right, because I just over and over again calculated the failure of our popsicle bridge. But I was far from perfect. Third year, 59% in quantum mechanics. And again, North American systems, good marks, well, average marks are 75, good marks are 85, great marks are sort of 93 and up. So you can still get into something, even if you almost fail what you say you have a passion for. From that, I went and did a master's and then PhD at the Institute for Quantum Computing. I built an entangled free space quantum key distribution system, bit of a mouthful. So entangled photons that worked across rooftops. So from a middle building on the campus, it went out to the IQC, and it went out to the Perimeter Institute. And really, I built or helped build most parts of it, from the photon source to the free space optics to and we bought detectors, but there was some other electronics around it that we had to get working, and all the software I wrote for it and stuff. So it was a lot of fun, challenging. And I started, that wasn't even the most challenging. I got hints of challenging experiments doing an oblivious transfer experiment that was very theoretical. Some wonderful theorists thought they'd written an experimental paper. It wasn't quite yet. There was still a lot of translation to do. So that was challenging. And then challenging logistically is we did a 3-photon experiment to violate a Mermin inequality. So we had actually a 4-photon source. You post-selected it to get 3-photon entanglement and distributed it to 3 different locations over free space links, again, about 1 kilometer away from each other in the dead of winter, with a central building in between. So fun fact number 2, again, because I didn't have the world's best marks, I started to pull up my socks, but I had to get very proactive to even get into a master's program. The usual way in Canada is you've got 93% and up. You've got a scholarship, so you're paid for, because profs are usually quite poor. So I had to do a lot of hard legwork to talk to a lot of profs and convince them that I was going to work very, very hard in my PhD and in my master's, and to give me a shot. So again, you don't have to go the usual routes. I did some non-standard stuff too. I did a contract for the Communications Security Establishment of Canada, so the Canadian version of the NCSC. helping them set up a quantum lab. It did lengthen my PhD studies. Certainly 1 or 2 profs were like, "Are you sure you want to do that?" But in the end, I think it gave me a broader experience. And we did set up a first startup, barely. I was young and naive. I did it mostly in name and not in follow through, but it was a first experience at it. And then I came to Bristol again, just so that proactivity continuing through. I cold called Jeremy, who was the head of the group, and said, "Are you hiring?" And he nicely said, "I'm not sure. Come for a beer and we will see." And I came to learn that chip-based approach and marry it with what I knew of sort of quantum encryption from a higher level. 2 years later, we had some of the world's first chip-to-chip QKD demonstrations, sort of in partnership with Phil and some others as students and postdocs at the group. I think I saw it in Jorge's slides, and I'm glad that he highlighted it, or maybe it was the channel. I mean, I was at the right place at the right time. Luck is involved, no matter how much people tell you it isn't, to be bumped up to lecturer. So I got involved in the Center for Doctoral Training. Certainly the first 2, if not 3 cohorts, I did quite a bit of stuff, helped set up the labs, help run the 2 projects you guys do you folks do at the end of the year. And had a great time. I got involved in CiQ because Waterloo is a very entrepreneurial university. So I sort of got in my blood of wanting to get this stuff out into the real world. And CiQ was a nice place, a nice thing locally, doing similar. So we did a couple of programs there. And the group was really good at supporting, how should I say it? Maybe it's sort of my bonus fact, non-name brands. I mean, there was money floating around for quantum, and I meekly can remember putting up my hand when we were trying to figure out how to use some more training money. And we could have added on to the CDT and that kind of thing. And I said, well, why not a startup incubator? That's what's missing if you want to get technology out there. And Jeremy, bless his soul, said, that sounds like a great idea. You're writing the bid. So I blanched at that. But worked with some great people to help write a bid, take it to interview and get QTech funded, which is now, I don't know how many companies we're up to, 20 plus, 16 are wanting our money. It's a shame it's sort of wrapping up or evolving into something different, but I'm quite proud of it. What was my key fun fact? My key fun fact there is I got to teamwork very, very late, even though I've done some decent things teamwork wise in my early school years. I was the king of the single person group project. I talked to myself a number of times on a recorded video as myself talking to an expert. Because I just found it incredibly annoying to collaborate, arrange schedules, divvy up tasks, was just all an annoyance. So I was not good at teamwork either early on. I came to it very, very late. And so now I'm CEO of KETS. So my 1 bit of KETS, you can see the screen. At KETS, basically what we figured to do is how to miniaturize quantum safe cryptographic hardware. So for starters, quantum random number generators and quantum key distribution systems into a size, into a form factor, and at a price point that makes it commercially interesting to telecommunications providers, data centers, defense and space, companies like that, customers like that. And it's easily integrated within their systems because it's this sort of nice, tightly tight chip-based approach. So that's sort of how I ended up where I did. I didn't really end up set out to do it. I certainly didn't have the perfect transcript to do it with. But hopefully in some of that, you can actually pick out some lessons. And I'm going to pause for a second just to see whether anything's coming up. No questions. Any questions in the Q&A? So there's a question in the Q&A. I'll make sure to come back to it. Couple of lessons you can take from that. Learn how to fail. Like I said, if you want a career in quantum, if you just want a career, I wasn't used to working hard, failing to solve things in the first go on a homework. I had to get used to looking myself in the mirror, forced me to develop some emotional intelligence, some grit, which came in very handy later on. I'll come back to in a second. And maybe if you're thinking about it in the CDT especially, lots of people grumbled, say, about that lab team projects. You had to do, you had to work with teammates. It was hard, you didn't have enough time, didn't really know what you were doing. But it actually, the purpose wasn't to succeed at the experiment. Just as importantly, it was to sort of work as a team and also learn how to fail, learn some lessons from it. That's the only bad failures if you don't learn a lesson from it. So you folks are probably, if you're in your PhD, the most, you probably not failed a whole lot. And it's a key skill to learn. So I'd encourage you to put yourself in situations that you won't necessarily succeed in, because otherwise it can come back to haunt you a little bit. I'll say a bit more about that in a second. Get proactive. I mentioned, because I didn't have the perfect track record, I had to work very hard. And the way I see this in students and people who want internships, want jobs, is when you're applying for a position, you got to step outside your bubble. You've written the perfect letter, you think, but it looks the same as the other 59 letters that we received. So how do you set yourself apart? There's no real spoon feeding here, like assignments and stuff. You gotta do the legwork. So research the company, figure out where your skill set might overlap, and take a guess. Show what you think you can bring. Because if I'm reading an application like that, I know this person's proactive. I know they'll take some initiative. I know they can take care of themselves and won't have to be spoon fed. So when you're applying for things, I mean, it's marginal, the extra work you have to do, but you can really set yourself apart with a bit of a proactive attitude. Because I'll take a hard worker capable of managing themselves over sort of a self-proclaimed genius any day, because there'll be a lot less work. They'll get a lot more done in the end. And the third one was learn how to work as a team. Again, I was very bored at this. Even for the QKD experiments, which were cool, I needed a team, and they probably could have been done in half the time, because I did work with some great people, but I didn't use them as well as I could have. We pulled off the Merman one. We probably had a team of 15. It was a lot of learning on the job, and we sort of succeeded by having a large team, so that when I made mistakes, the core team of sort of 8 or 9 of us still got the job done. So yeah, everybody's asking about the company. Okay, I'll finish up quick so I can answer all your questions. How do you put it to use now? In terms of failure, remember that grit. If you want to get into startup land, especially, our first Innovate UK grant got turned down not once, not twice, but third time was when we finally got it through. So learning how to fail and learn from it is key. When we got seed funded, I went back to look at my spreadsheets. I had 134 entries in it. So that's what it took to get seed funded. For our latest fundraising round, I had 63 entries. So at least I'm getting better, I guess, in terms of ratios. But a lot of people said no. So if you can't learn to fail and pick yourself up, certainly in startup land, you're not going to have a good time of it. And now, internally, a large part of my job seems to be encouraging team members to reset their attitude and take one of a moonshot attitude. So we're going to try difficult things rather than just try and do safe things that we know we can deliver on. The proactive bit, I mean, this is business development in a nutshell. We need to get companies interested in their products. We need to prove our worth. We need to show early products that aren't ready yet, figure out what's of value to the customers, what's their drivers. I mean, this is 250% proactivity to succeed, because you cannot wait for them to come to you and tell you what they need, because probably they don't know what they need. You're going to have to dig it out of them. And the last bit about team is, I mean, tech is easy, people are hard. And also anything of value now, regardless of whether this came up in an earlier conversation this morning, regardless of whether you're in a startup or even if you're in an academic group, they take a team. Every student wants that Nature paper with the lead authorship, and most of the low-hanging fruit in quantum information is now done. There's very few Nature papers that only require one person to do them anymore. So even if you stay in academics, learning how to get along with the team is key. And you're going to have to figure out how to balance sort of directing with leading, with following, with coaching and stuff. So anyways, that was, from the looks of it, completely different as a talk than what you got this morning. And it sounds like you're more interested in KETS, the company. So happy to go to your questions now. So do write more either into the Slack channel, which I'm going to bring up, or into just the channel of the Q&A for Zoom. What do we got?
Yeah, you should be able to see quite a few in the Q&A, Chris.
So PC Gamer Me recognized the QED devices looks like a GPU, PCI X16 slot. Yep, I guess you could add it to your gaming PC. Again, that comes from that sort of tenacious, proactive attitude. We went and talked to a lot of customers, and we're focused on telecommunications providers, data centers, and defense and space. And generally, the first use cases are protecting communication lines, and that amounts to sticking something into a server. So unsurprisingly, PCIe card can go in a server because most servers have that kind of a slot. And in other cases, even when you're putting it into hardware security modules and stuff, it's, again, they have a PCIe slot. It's small enough that you can benefit from their secure enclosures and stuff. So sorry, that's a long-winded way of saying, yes, it's like a GPU card. It's a PCIe card. And our random number generator sat in our server winning our office football pool at the moment, which probably says something about the English Premier League. So you could add it to your gaming PC. You'd need to cough up a pretty penny, but you absolutely could. What's KETS trying to achieve? We need a better tagline because it's sort of what's on the screen. When you get into a company, the technology sort of fades to the background and your mission and your vision comes to the fore. We really honestly want to do this, build a world in which you can trust your digital connections just as much as your personal ones. Sort of that KETS inside sticker means that you trust your laptop, you trust your phone, because you know there's some technology in there that's going to keep your data safe. And it just happens to use some quantum technologies to do it. But that's what we're honestly trying to achieve as a mission. Like to know about your funding structure. I personally think the largest threat to security of private communication are governments. They seem to be involved whenever any cryptographic research is going on. I find QKD really interesting, but I don't want to enable governments to spy on the people. Quite the opposite. Are you funded? Do you collaborate with government agents? We collaborate with governments. You're not going to get away from this because that's some of the key use cases. It is a bit of a double-edged sword. They certainly want to keep all of their government communications safe and read everybody else's. So that's why you will have contradictory statements from governments, but they are some of the key use cases. So you do have to work with them. They're your customers. I do want my MP's communications to be secure. I want the US's communications to be secure. I want everybody's communications to be secure. The UN sort of said it best. Privacy is a fundamental human right, and we'd like to enable that. But we're in the commercial sphere. We're going to get vetted by third-party security assurance providers, FIPS, Etsy, the like. So I'm not so worried that we'll have any backdoors in us. Yeah, that's for the security. That's exactly why you do security assurance. They can do that for you. Jorge, do you feel the market is better informed of what quantum tech can offer now compared to when KETS started? What about potential pool of employees? Yes. Our seed funding, partly that laundry list of investors we had to talk to was so long because it was a lot of education as well. Now the market in quantum's a hot topic. The investments are going up. The news articles are going up. So much better informed. Pool of employees is bigger because of things like the CDT, though it's good not to miss the fact that the pool of employees is not just quantum, which is why even if you're in the CDT, it's good to keep your electronics sharp or your software sharp. Multidisciplinarity is key because we need electronics people, software people, all alike, as well as people that can make quantum chips. Can you level out a learning pipeline to understand QKD and its application, quantum information communication? Can you level out a learning pipeline understand QKD and its application of quantum information? I don't know that I understand the question. You want to try again, Daniel, at the bottom? I'll move on. Sorry, I just don't get the question and I'm conscious of time, but try again. Currently working with one of my colleagues on industrial project. Oh, cool. Thanks. Welcome, Vaibhav. I don't think I've met you yet. That's great. Can this be extended to a job position? Ballsy? Quite possibly. We go through our normal channels. Great that you're interested. Great that you're working with us. So the possibility is absolutely there. Similarly for sort of joint PhD, the possibility is absolutely there. Obviously not going to do that on the fly on a talk. But I appreciate the ballsiness. I should pick a better word for it. The brashness. When will we have QKD in the field? Insurances, the current classical and crypto. It's a couple of years' time. Etsy's doing a lot of good work. ITUT, ISO. It's taking longer, but cyber and properly vetting things takes a long time. The NIST competition will have been going for 6 or 7 years for post-quantum encryption solutions by the time they finish. And that doesn't stop. Some of the best security talks I've seen is from hackers and just talking about picking classical locks and doing it with tennis balls and all sorts of crazy things. See whether I get to the last one. How is KETS different from quantum communication companies like ID Quantique. Chips, I guess you can't see it in the picture on the screen, but we're taking this chip-based approach that we pioneered at Bristol, and already it lets us do form factors like a PCIe card that's smaller than competitors. And it doesn't stop there. The first go for some of the devices, we're starting with some rack-mounted stuff for some, then to PCIe card, then imagine a mobile phone daughter board, and eventually get it to the promise is down to a little black pick package that can just be ubiquitous and go anywhere. And I think I probably have to shut up now because I'm a minute over, unless Reach lets me go any farther.
No, thanks, Chris, for all of those. I guess there are a couple more questions. We're moving into a break after the next talk anyway. So there's a question about Vadim Makarov, which you might be able to see.
Oh, yeah.
Chat, which is interesting. And one on CVQKD as well.
Yeah, happy to answer both of them. So CV we're thinking about. It has you can't go as far with it, but for shorter distance applications, and there are some use cases we're looking at, you can get higher rates. So yep, we're working on it. Have you heard that? Yep, I know Makarov well. We overlapped at IQC, and he is hacking, or in partnership with actually my last student, Frederica, who's part of the Bristol CDT. She's the one leading the work and has been working with Makarov, amongst others, to try and hack some of the chips that we have. And sadly for her, it's turned out to be hard. Good for KETS, it's turned out to be hard. But she's the person to follow up with. And anybody with a CDT link should be able to easily get in touch with her.
Great, thanks, Chris. I guess we'll wrap it up there for now. I'll move your other questions onto the Slack in a bit if you're on there, and hopefully you can answer them. And if people have more questions about KETS and anything.
Yeah, absolutely. Sorry, the other thing I should have mentioned is I'm not on my game today, but we are, I think, hiring for some roles. So I'll connect the right people at Careers in Quantum and make sure that gets disseminated. Worst case scenario, just come to our website and it's in the career section there.
Great. Thanks a lot, Chris. I really enjoyed that.
No worries. Thanks, folks. Thanks for the opportunity, and thanks for the wonderful, I'm not drinking my beer yet, but thanks for the wonderful opportunity and gift bag.
Yeah, we're nearly there. Cheers, Chris. So